So today we're talking about solving equations that have an absolute value. And if you remember on the test, we had a problem that was the absolute value of y equal to 5. And some of you told me, well, y is equal to 5. And really, that's only half the story. If I took the absolute value of 5, I would in fact get 5. So it works. The positive 5 works. But what if I let y equal -5, so I take the absolute value of -5. I'm still getting 5. Both cases give me 5. So the answer to that was a plus or minus 5. I really need to consider both cases of something. Likewise, there was a problem that said the absolute value of x equals something like -6. And some of you told me that x was -6. But if I plug that in, the absolute value of -6 is 6. There's nothing I can totally plug into x inside of the absolute value signs that will give me a negative when I take that absolute value. So this doesn't work. In fact, you'll find out nothing works, and this is really a no solution. Okay? So this plays into a lot of what we're going to be doing today, which is when we have something inside absolute value, but maybe that it's not just y, it's something like f plus 5 inside of the absolute value, and we set that equal to 17. And we want to consider all the cases of what f could be, okay? So I'm going to do something a little tricky, and I'm going to consider two cases. The first one, I'm going to drop, well, in both cases, I'm going to drop the absolute value signs, and I'm just going to say f plus 5 equals 17. That's pretty basic. It's, if f is, you know, a nice number that we know plus 5, it gives us 17, we solve real easily. Case 2 is the part that gets a little tricky, because I'm going to consider that what's inside the absolute value could give me -17. When I take the absolute value of -17, it gives me the positive 17. So I'll say f plus 5 equals a -17 inside the absolute value. And then I go ahead and solve both of these. These are one-step equations. These are things you know how to do. I subtract 5 on both sides. I get f equals 12. I subtract 5 on both sides. I get f equals -22. And it may seem odd that I have two different answers. Both of those are correct. But if I went back and I plugged those in to my original equation, if I had 12 plus 5, the absolute value of that, well, I do what's in the absolute values first. So 12 plus 5 is 17. The absolute value of 17 is 17. Likewise, if I have -22 plus 5, that gives me -17. I take the absolute value of -17 and I get 17. So you can see by checking that both of those answers do in fact work, and that's why I have to consider both cases of it. I'm going to give you one to do on your own. The absolute value of y plus 2 equal to 4. So consider both cases, and then I'll show you how I worked it out. So in case 1, I say y plus 2 is equal to 4. I subtract 2 off both sides. I get y equal to 2. In case 2, I say y plus 2 equals -4. Remember, I'm setting it equal to that negative number. I subtract 2 off both sides, and I get y equal to -6. Now I want to check to make sure both of those work. So if I plug it in, The absolute value of 2 plus 2 is the absolute value of 4. The absolute value of 4 is 4. In case 2, negative 6 plus 2 gives us negative 4. The absolute value of negative 4 is 4. I know the two different cases can sometimes throw you off, and it's something that you really have to practice with. But this is really important in algebra, so we're going to be practicing a lot more with this tomorrow in class. See ya!